So my lab looks at how the immune system can affect mental health in people living with HIV. We know that with medication, HIV is really well controlled right now, but we see a disproportionate amount of people living with HIV that also have a lot of mental illness, things like depression, anxiety, things like that. And so my lab looks at inflammation in immune cells to really figure out just how maybe those things connect and how that can explain the mental illness that we see with HIV. And why that's really important, if we figure out this inflammatory component, we can kind of guide treatments to improve quality of life for this population. I think it's really important, and a lot of people might not know this, that HIV affects the immune system, but it really affects the brain too. And those both, interact really closely. So being able to understand those and, for my research, how certain medications can impact those things, how that can alter, mood, memory problems, things like that, is just really important, as I said, just for kind of giving better quality of life for people with HIV. We have medication, as I said, that keeps it well controlled, so it's not really a lifespan issue anymore, it's more of a health span. So that's what a lot of my research is focused on. So it was actually just seeing a lot of family members suffer taking multiple medications. I mean, not necessarily in the HIV field, but just in general. It's also called polypharmacy. So just seeing, people that I love struggle with, this burden of medication made me really think about drug-drug interactions, how that, affects the body, and really shaped my research to understand how things like antiretroviral therapy and antidepressants can be affecting inflammation and treatment outcomes for people with HIV. Mentoring all the way. For me, because as I said, I teach a course in neuropharmacology. I'm also mentoring students all the time, teaching them how to run their experiments at the lab. And really, it brings me no greater joy than just seeing students that are motivated, that really have the passion, and they're building their skill set. It's really cool to see. I have a technician right now that when he first started working with me was like learning how to do a pipetting test. And now he can take 2-day-long experiments with the patient samples that we get from the CNHC, and running these experiments without my help, and it's just really incredible. So we're, with the help of my technician, we've been collecting a lot of data for kind of the big project that I work on with the CNHC. We're kind of almost wrapped up with the basic science data. So what I mean is like the inflammation data with the immune cells. What I'm really excited is to work with people at the CNHC, like psychologists, biostatisticians, and try to figure out, what the stuff that I've figured out, how that correlates with like, real-world patient characteristics. So if we find that inflammation is really high in a specific gender or age, or because they're taking a certain medication, being able to kind of pinpoint why that's happening and maybe try to mitigate that, I think is really exciting. Yeah, so they've been awesome, and they really started a whole new project in my lab that I never thought I'd be able to do before. So I've been working with immune cells for a really long time, even with rodents, pigs, humans, a lot of different models, but never like real-world patients. So being able to get these cells from the CNHC and being able to work with them and being able to look at, as I said, like real-world characteristics and get straight to the patients while still doing like this bench work, I think is really cool. Yeah, definitely. Yeah, so couldn't do it without them. One thing, and I didn't even do HIV research until I was a postdoc, so I've learned a lot in that time. It's been pretty cool, but I think one of the interesting things is that HIV can actually reach the brain less than a week after infection. And the cells that I study, like from the blood, they can actually crawl through brain barriers and infect cells in the brain. And actually the HIV that's in the brain can hide. I don't know a better way to say it. HIV researchers call it HIV reservoirs, and that's why it's so hard for medication to completely eradicate the virus. So, if you hear, people living with HIV, they have undetectable levels, but it's actually still there, changing their biology. And so that's why I think it's just so important to understand, all the medications this population takes, because they might be responding to it differently.
That is really interesting.
Yep.
HIV reservoirs.
Yep.
Which the medication is not.
Can't target, can't see.
Wow.
And so, because, if the virus is out in the open, immune cells are going to try to attack the virus. But if it's hidden, there's no way for the cells to know that it's there. So people are trying different therapies. They haven't, obviously they're not in the market. This, is still ongoing. We're trying to figure out if this technology is actually going to be useful. But I think it's pretty cool, the strategies that they're using to try to figure this out. Yeah, and you can see this happening in other organs as well, like not just the brain. So yeah, monocytes, I guess I'll just say this anyway, the immune cells that I look at, they're called monocytes when they're in the blood. And then when they move to different organs, like the brain or the liver or something, then they become macrophages. And then they communicate with the other macrophages, like in those tissues, and infect them as well. But HIV can infect every cell type. Like neurons of the brain, HIV can infect those. So that's kind of another fun fact too. But the cells that are infected can damage those neurons, and that's why we think maybe that causes some of the cognitive dysfunction that we see. So for this, for me, I think it's really about understanding, the different medications, as I said, that people living with HIV take. When I was first looking into this research and reading the literature, there's no specific guidelines for people with HIV and what type of antidepressant they should take, for example. It's just, standard first-line SSRI. It doesn't really matter what other diseases you have. And unfortunately, a lot of studies, when they're looking at whether or not, these drugs are tolerable, a lot of times they exclude, people with other diseases like HIV or, other viral infections like hepatitis or things like that. So, as I said before, if HIV is changing a person's biology, you don't know if they're going to respond to the drug in the same way. So for me, I'm really hoping that I can create some data that really has that real world impact on deciding, is that really the right drug? Should people be taking drugs, alternative antidepressants, anxiety reducing medications, what's that right combination paired with the right type of antiretroviral therapy. And as people age too with HIV, they actually age faster. They call it an accelerated aging kind of characteristic. So, people may have mental illness, but also higher rates of, cancer, heart disease, things like that. And then when you put all those medications into the equation too, it just gets really burdensome. So if we have any data to suggest kind of how to, as I said, create guidance for these, I think that's what's going to be really important for the community. I was also going to say too, there's a lot of literature suggesting if someone is already living with high inflammation, regardless of HIV, that certain antidepressants may actually be more anti-inflammatory and more useful. For example, Wellbutrin, which works more on dopamine, may have a better effect than SSRIs that work more on serotonin. So it's more about that pharmacology, and again, going back to just how the chemicals of the brain are interacting with the immune system. But we don't know what's happening specifically with the HIV population. So that's where I'm kind of trying to create that niche. For me, I think I could have a lot of answers to this, but the first one that came to mind was just be prepared to wear a lot of hats. Every week is different, so having to pivot between analyzing data, writing grants, writing up manuscripts, teaching students in the class, or doing the experiments yourself, is just always just so much going on. So staying organized, because I'm pretty bad with that. So I wish I had done that better. I have a lot of, if only I did this better, that would create a lot less work for current staff. But It is what it is. And then just like learning to pivot as well and just being flexible while being organized is just such a challenge. So I do find the job pretty chaotic, but at the same time, pretty rewarding too. Yeah. I think the biggest thing I could say, and I know it can be scary sometimes, like especially if it's a junior student or something like that, but don't be afraid to ask to collaborate. Because HIV is so interdisciplinary, you need an interdisciplinary team. So like for example, I came from neuroscience, didn't really have much of an HIV background. So really with the help of, immunologists, statisticians, clinicians, all them working together just makes the research so much stronger. So, don't do your work in isolation, and, what's the worst that can happen if you reach out? So that would be my biggest piece of advice. Just go for it.